Yesterday we started section 5.2 on polynomials. So I gave you some terminology. So a polynomial consists of terms that we add together. A term consists of two parts, a part consisting of a number called the numerical coefficient, and a part that is consists of a variable to some whole number exponent. The degree of a term is the sum of the sum of the exponents of each of the variables. The degree of a polynomial is the largest of the degrees of the term of each of the terms in your polynomial. If there is only one term in your polynomial, we call it a monomial. Two terms, binomial. Three terms, trinomial. The constant term, a constant polynomial is a polynomial of degree 0. A linear polynomial is a polynomial of degree 1. Quadratic, polynomial of degree 2. Cubic, polynomial of degree 3. Quartic, polynomial of degree 4. Kentic, polynomial of degree 5, etc. The leading order coefficient is the coefficient corresponding to the term with largest degree. And if there's more than one term of largest degree, then it's the one that comes first in alphabetical order. A monic polynomial is one whose leading order coefficient is equal to 1. Let me do some examples. Page 190. Problem number 1. In exercises 1 through 10, identify the algebraic expressions which are polynomials. 3x squared plus 5x minus 7. This is the sum of several terms, so therefore this is a polynomial. 3. 4x plus 3 minus 7x squared. Again, this is the sum of three terms, each of which is consists of some numerical coefficient with a variable to some whole number exponent. So therefore, yes, this is again a polynomial. Five, 3x squared plus 1 over x plus 2. This is not a polynomial because 1 over x is not x to some positive whole number exponent, so this is not a polynomial in x. Oops. Okay. Maybe I should say in what variable. So this is a polynomial in x. Polynomial in x. This is actually called a rational expression in x. So it's not a polynomial, it's something else that we will study in the future. 7. 3x cubed minus 1 over x squared. Again, this would look like 3x squared, x cubed divided by x squared is x, minus 1 over x squared. So this is, again, not a polynomial in x, because you have something as 1 over x squared. So this is not x to a whole number exponent. So this is not a polynomial in x. Again, this is rational in x. Number 9. P 3p squared plus 4p minus 1. So if you look at this, this is just going to be 3p cubed plus 4p squared minus p. And, well, again, this consists of 3 terms. Each term consists of some coefficient, some number, times p to some whole number exponent. So this is a polynomial in the variable p. 11. 3x squared plus 7x minus 3x to the 4 plus 4x to the 3. In exercises 11 through 18, write the polynomial in descending orders of powers of the variable. Also find the degree and the constant term in each case. Okay, so let us rewrite this where it's in descending order. And so I want to write the terms with highest degree first and go down in degree of each term. So a negative 3x to the 4th plus 4x cubed plus 3x squared plus 7x. So I've rewritten this in descending order. The degree of this polynomial is, well, the highest power of x is 4. The constant term the one that doesn't have a variable in front of it is, whoa, there's none of them. So is 0. So the constant term in this case is 0 because that's the only thing that doesn't have an x in front of it. Let me do problem 13. 7x squared plus 8x cubed minus 5 minus 4x to the 5th. So let's write this in descending order. Negative 4x to the 5th plus 8x cubed plus 7x squared minus 5. And so I've written this in descending order. The degree of this polynomial is 5. The constant term is negative 5. X to the 4 minus 3x to the 5th plus 7x to the 6th minus 9x to the 8th. And so, writing the descending order, negative 9x to the 8th plus 7x to the 6th minus 3x to the 5th plus x to the 4th. And so this is my polynomial written in descending order. The degree of this polynomial is 8. The constant term in this case will be 0. 17. Negative 6 x to the 4 plus 7x to the 5 minus 4x squared minus 2x cubed plus 1. This is equal to 7x to the 5 minus 6x to the 4 minus 2x to the 3 minus 4x to the 2 minus 1. And so I've written my polynomial in descending order. The degree of this polynomial is 5. The constant term is negative 1. 19. 3x squared minus 1. In exercises 19 through 30, identify which is a monomial, binomial, trinomial, or another type of polynomial. What is the degree of the polynomial? Okay, so in this case, there are two terms. So this is a binomial. And the degree of this polynomial is 2. So it's quadratic. 21. 4x cubed. Well, this is a monomial because there's only one term. And the degree of this polynomial is 3. So this is a cubic polynomial. Let me do problem number 23. 12x cubed plus 3x. There are two terms, so this is a binomial. The degree of this polynomial is 3. So this is a cubic polynomial. 25. Negative 3x to the 5th plus 7x squared plus 9. There are three terms. Therefore, this is a trinomial. And so I have that the degree of this polynomial is 5. This is a kinetic. Let's do 27. 15, x to the 10 plus 16, x to the 8 minus x to the 4 plus 2x. 1, 2, 3, 4. There are 4 terms. We really don't, past 3 terms, we really don't give it any special name. So this is just, there's really no special name for this polynomial. So we just, it's some type of polynomial. It's a polynomial with 4 terms. The degree of this polynomial is 10. Let me do problem 29. X squared plus 2x plus 1. Having a parentheses really doesn't make any difference. There are 1, 2, and so maybe I should say that this is the same as x squared plus 2x plus 1. So there are 3 terms. So this is a trinomial. And the degree of this trinomial, degree of this polynomial, will be 2. So this is quadratic. 31. 3x squared minus 7x plus 5. Okay, so in exercises 31 through 38, evaluate the polynomial when x is equal to 2 and x is equal to negative 2. So first let's evaluate. When x is equal to 2. So 3x squared minus 7x plus 5. Whenever you do a substitution, please put a parentheses around the object you are substituting into. 2 squared is 4. 7 times 2 is 14. 12 minus 14 plus 5 is 3. 12 plus 5 is 17, minus 14 is 3. Evaluate. When x is equal to negative 2. So I have 3x squared minus 7x plus 5. Negative 2 squared is 4. Negative 7 times negative 2 is a positive 14 plus 5. 12 plus 14, 26 plus 5, 31. Let me do problem number 33. Negative 4x cubed plus 3x squared plus 10. So let's evaluate this. when x equals -2, when x equals +2, -4 x cubed plus 3 x squared plus 10. -4 times 8 plus 3 times 4 plus 10. -32 plus 12 plus 10 is equal to -10. -32 plus 12, -20 plus 10, -10. Let's evaluate. When x is equal to -2, so -4 x cubed plus 3 x squared plus 10. So -4 times -2 cubed is -8 plus 3 times yes. So the degree of this polynomial is 3. The degree of this term is 3 because that's well, if it's only one variable, then the degree of a term is just the exponent of the variable. So the degree of this term is 3. The degree of this term is 2 because that's the exponent. The degree of this term is 0. The degree of the polynomial is the highest of those, 3, 2, and 0. And so the degree of the polynomial is the highest degree of all of the terms in the polynomial. Okay? -2 squared is 4 plus 10. Negative times negative is positive. 4 times 8, 32, plus 12, plus 10. 32 plus 12 is 44, plus 10, 54. Let me do problem number 35. Negative x to the fourth. Oh, and I guess I should say that really the reason that we talk about degrees of terms is really useful when we have more than one variable. So if you happen to have like x's and y's and z's, then that's when you have to worry about, because then it's not so obvious what the quote unquote degree of the polynomial is. So you have to then check each of the degrees of the terms. Yes. So if I had x to the fifth, y cubed plus 8x 5 to the fourth, yz to the fifth, and maybe we'll put a 2 here, then the degree of this term is 8 because you add 5 plus 3. The degree of this term is 11 because you add these terms, but the degree of the polynomial is 11 because that's the highest, the largest of these numbers. Yeah, so it's when more than one it's not as obvious when you have more than one variable, When you just have one variable, you just look at the highest power, and it's easy. Whereas here, it's not, when you have more than one variable, it wasn't so obvious that the degree was 11. Yeah. So in one variable, we're just looking at one variable now. Then it's easy. For multiple variables, then you have to worry about a little bit more. Okay. $35. Negative x to the 4 plus 4x to the 3 minus 29. So let's evaluate when x is equal to 2. So negative x to the 4 plus 4x to the 3 minus 29. X to the 4th is 16. X cubed is 8. So I have here negative 16 plus 32 minus 29 is equal to negative 16 plus 32 is 16 minus 29 is negative 13. Let's evaluate. When x is equal to negative 2. So I have negative x to the 4 plus 4 x cubed minus 29. Negative 2 to the 4th, 16. Negative 2 cubed, negative 8. Four times negative 8, negative 32. Negative 16 minus 32, negative 48 minus 29 is negative, so 48, 60, no, okay, let me do this again. Let's see, that's 48, 48, 87, no, that's correct. So negative 48 minus 29, so 48 plus 29, 60. I keep getting 77 in my head. Okay, 16, 32, 29, 8, 17, carry the 1, 5, 6, 7. Yeah, well, I'm wrong. Okay. That's 4, 6. Okay. Negative 77. Sorry about that. So it's negative 77. I was arguing with myself in my head. So 37. Let's do problem 37. 11x to the 4 minus 9x cubed plus 2x squared plus 10x minus 5. Evaluate when x equals 2. $11 x to the 4 minus 9 x cubed plus 2 x squared plus 10x minus 5. Okay. 2 to the 4th, 16. 2 cubed, 8. 2 squared, 4. 10 times 2, 20, minus 5. 11 times 16, 176. 9 times 8, 72. Plus 8, plus 20, minus 5 is equal to 23.99. Okay, so let's do this. 176 minus 72, 104, plus 8, 112, plus 20, 132, minus 5, 127. Let's evaluate. When x equals negative 2. So 11 x to the 4 minus 9 x cubed plus 2 x squared plus 10 x minus 5. Negative 2 to the 4th, 16. Negative 2 cubed, negative 8. Negative 2 squared, 4. 10 times negative 2, negative 20, minus 5. 11 times 16, 176. Negative times negative positive, 9 times 8, 72. 2 times 4, 8. Minus 20, minus 5. $176 plus 72, 100 and so it's 248 minus 8, 240. 240. Oh, wait. Plus 8. Oh, start that over again. 176 plus 72, 140, 248, 200 plus 8, 256, minus 20, 236, minus 5, 231. Okay, good. Let's do problem number 39. 4x cubed, 7x squared, minus 5x, 3x squared, plus 7. Okay, so in exercises 39 through 50, add the polynomials. So you can add polynomials when you add like terms. So let me do this in descending order and see if they're like terms. If they're like terms, then I'll combine those like terms. So I have here, well, let me actually get rid of all the parentheses. So I have here a 4x cubed. There are no other x cubed terms. So this is 4x cubed There's a 7x squared and a minus 3x squared. Well, 7x squared minus 3x squares. 7 apples minus 3 apples is 4 apples. So 4x squares. There's no other term than 5x, and there's no other term than 7. I've combined all my like terms. None of these terms here remaining are like terms, so I'm done. And so I can combine like terms. Unlike terms cannot be combined. Two terms is said to be like terms if their variable parts are identical. When I say identical, well, maybe see, are the same. Well, if you write them in the same, you can combine after simplification. After simplification. So if you had like 2x times x squared, that's the same as 7x cubed, because you could multiply the x and the x squared together to get an x cubed. Okay, let me do 41. Negative 5x to the 4 plus 7x cubed plus 8x minus 9. Let's add to that. And I'll actually just add by putting terms underneath each other. So plus 6x to the 4th plus 9x cubed plus 10x squared plus 9. So let's add these together. So the 6x to the 4th minus 5x to the 4th is x to the 4th. 7x cubed plus 9x cubed is 16x cubed. There's no matching x squared term, so this is plus 10x squared. There's no matching x term, so plus 8x. 9 minus 9 cancel, and so my answer is x to the 4th plus 16x cubed plus 10x squared plus 8x. Do problem 43. For p squared plus 7p minus 2 plus 3p squared minus 8p plus 4. And so, adding these, I get 7p squared minus p plus 2, combining like terms. 45. 6z cubed plus 7z squared minus 8z plus negative 8z cubed plus 4z squared plus 10z minus 2 plus 2z cubed plus 9z minus plus 2. Get rid of all the parentheses. 6z cubed, 7z squared, minus 8z, minus 8z cubed, plus 4z squared, plus 10z, minus 2, plus 2z cubed, plus 9z, plus 2. 6z cubed, minus 8z cubed, plus 2z cubed. Oh, the z cubes cancel. You have 8z cubed minus 8z cubed. 7z squared plus 4z squared is 11z squared. Minus 8z plus 10z is 2z plus 9z is 11z. 2 minus 2 cancels. And that is your answer. 47. Minus 3y cubed plus 2y squared minus 8 minus 3y squared minus 5y plus 9 y cubed minus y squared plus 6y. Let me get rid of all the parentheses. Minus 3y cubed plus 2y squared minus 8 minus 3y squared minus 5y plus 9 plus y cubed minus y squared plus 6y. So let's look at the y cubed. Minus 3y cubed plus y cubed is minus 2y cubed. 2y squared minus 3y squared is a minus y squared minus another y squared is minus 2y squared. Minus 5y plus 6y is 1y. Minus 8 plus 9 plus 1. And that is the sum of all those polynomials. 49. Four y cubed minus 3y squared minus 2y plus 1 plus 7y squared minus 7 plus 3y cubed plus 7y minus 8. Let me get rid of all the parentheses. 4y cubed minus 3y squared minus 2y plus 1 plus 7y squared minus 7 plus 3y cubed plus 7y minus 8. 4y cubed plus 3y cubed is 7y cubed. 3 minus 3y squared plus 7y squared is 4y squared minus 2y plus 7y is 5y. 1 minus 7 is minus 6. Minus 8 is minus 14. And that is your answer. 51. 2x squared plus 3x plus 3x squared plus 4x. In exercises 51 through 65, simplify the given expression. Two x squared plus 3x plus 3x squared plus 4x. Combine like terms. 2x squared plus 3x squared is 5x squared. 3x plus 4x is 7x. 53. 4a squared minus 3a plus 4, 2a squared plus 6a plus 2. So I have 4a squared minus 3a plus 4 plus 2a squared plus 6a plus 2. 4a squared plus 2a squared is 6a squared. Minus 3a plus 6a is 3a. 4 plus 2 is 6. There are no other like terms, so you're done. 55. Minus 6p squared plus 7p plus 2 plus 5p squared plus 3p minus 1. 5p, and so this is negative 6p squared plus 7p plus 2 plus 5p squared plus 3p minus 1. I have here a negative 6p squared plus 5p squared, negative p squared, 7p plus 3p, 10p, 2 minus 1, 1. And that is your answer. 57. 5x squared minus 3y squared plus 3x squared minus 2xy plus 6y squared. So this is equal to 5x squared minus 3y squared plus 3x squared minus 2xy plus 6y squared. And so I have 5x squared plus 3x squared is 8x squared. I have minus 2xy, 3y squared, negative 3y squared plus 6y squared is 3y squared. So I am done. 59. 5t cubed minus 7t squared plus 8t plus 4t cubed minus 6t squared plus 4t plus 3. So getting rid of parentheses, 5t cubed minus 7t squared plus 8t plus 4t cubed minus 6t squared plus 4t minus 3. 5t cubed minus 5t cubed plus 4t cubed is 9t cubed. Minus 7t squared minus 6t squared minus 13t squared. 8t plus 4t, 12t, and then just minus 3. And that is your polynomial. 61. Minus 4 r cubed plus 7r plus 9 plus 6r cubed minus 7 minus 8r squared plus 10. Then get rid of all the parentheses. Minus 4r cubed plus 7r plus 9 plus 6r cubed minus 8r squared plus 10. 6r cubed minus 4r cubed, tr cubed, minus 8r squared, 7r plus 7r, 9 plus 10, 19. $63. Two x squared plus 6x plus 12, 5x squared minus x plus 4. Getting rid of all the parentheses. 2x squared plus 6x plus 12 plus 5x squared minus x plus 4. 2x squared plus 5x squared, 7x squared. 6x minus x plus 5x, 12 plus 4, 16. And that is the sum of those two differing polynomials. 65. Negative 5r cubed minus 6r squared plus 3r plus r squared minus 5r minus 8. Get rid of parentheses. Minus 5r cubed minus 6r squared plus 3r plus r squared minus 5r minus 8. So I just have minus 5r cubed minus 6r squared plus r squared minus 5r squared, 3r minus 5r minus 2r. Then I just have minus 8. So that's the sum of these two polynomials. 67. In exercises 66 through 75, perform the indicated operation. Subtract 3m cubed plus 5m plus 5 from, so the next one will come first, 4m cubed plus minus 5m plus minus 5. So in problem 67, I want to subtract 3m cubed plus 5m plus 5 from 4m cubed minus 5m minus 5. And so this is equal to 4m cubed minus 5m minus 5. Change all the signs inside the parentheses. Minus 3m cubed minus 5m minus 5. 4m cubed minus 3m cubed, m cubed, minus 5m is minus 10m, minus 5 is minus 10. And that is your answer. 69. Subtract minus 4y to the fifth minus 7y to the fourth plus 9 from 3y to the fifth minus 6y to the fourth minus 7. Uh, 3y to the fifth minus 6y to the fourth minus 7. Okay, so let's get rid of parentheses. 3y to the fifth minus 6y to the fourth minus 7. Change all the signs inside the parentheses. Plus 4y cubed plus 7y to the fourth minus 9. So this is equal to, well, there's only one 3 to the fifth term, y to the fifth term. So 3y to the fifth, only one, 7y to the fourth minus 6y to the fourth is y to the fourth. There's only one y cubed term, so plus 4y cubed. No y squared, no y term. Minus 7y minus 9 minus 16. And that is your answer. 71. I want to subtract x squared plus 5x minus 8 from x squared minus 2x plus 1. Getting rid of the parentheses, x squared minus 2x plus 1. Changing all the signs inside the parentheses, minus x squared minus 5x plus 8. Combine like terms, the x squares cancel. Minus 2x minus 5x minus 7x. 1 plus 8, 9. 73. Subtract x cubed, negative x cubed, plus 3x minus 2 from negative 2x squared minus x plus 4. Then we get rid of the parentheses. So negative 2x squared minus x plus 4. Changing all the signs inside the parentheses. Plus x cubed minus 3x plus 2. And so combine like terms. Well, I just have 1x cubed, 1x squared term. Minus x minus 3x is minus 4x. 2 plus 4 is 6. Let me do problem number 75. Subtract negative 3x cubed minus 4x plus 1 from 4x cubed plus 5x squared plus 10. Getting rid of the parentheses, I have 4x cubed plus 5x squared plus 10. Subtracting, change all the signs inside the parentheses. I have plus 3x cubed plus 4x minus 1. 4x cubed plus 3x cubed, 7x cubed. 5x squared is the only x squared term. Plus 4x, that's the only x term. 10 minus 1 is 9. $77. In exercises 76 through 90, perform the indicated subtraction. Negative 9 t to the fourth plus 7 t squared minus 1 minus negative 9 t to the fourth plus 8t squared plus 10. Removing parentheses, negative 9 t to the fourth plus 7 t squared minus 1. Changing all the signs inside the parentheses, plus 9 t to the fourth minus 8t squared minus 10. So this is equal to the 9t to the fourth cancel. 7t squared minus 8t squared minus t squared. Minus 1 minus 10 minus 11. $79. 3 n to the fifth plus 4 n cubed minus 7 n squared plus 8 minus 4n to the fourth minus 5n cubed plus n squared minus 4. Get rid of all the parentheses. 3n to the fifth plus 4n cubed minus 7n squared plus 8. Change all the signs inside the parentheses. Minus 4n to the fourth plus 5n cubed minus n squared plus 4. Combine like terms. 3n to the fifth minus 4n cubed, 4n to the fourth. I have a 4n cubed plus 5n cubed is 9n cubed. Minus 7n squared minus n squared minus 8n squared. No n's. Plus 8 plus 4 is plus 12. And that's your answer. 81. Y squared minus 2xy minus 3y squared plus 4xy. So this is equal to, get rid of all the parentheses, y squared minus 2xy minus 3y squared minus 4xy. Y squared minus 3y squared is a minus 2y squared. Minus 2xy minus 4xy minus 6xy. 83. Minus 2x cubed plus x minus 1 minus negative x squared plus x minus 4 is equal to negative 2x cubed plus x minus 1, changing all the signs inside the parentheses. Minus and minus become a plus x squared minus x plus 4. Combining like terms, negative 2x cubed plus x squared. The x's cancel. 4 minus 1 is 3. $85. 3y squared minus 2y minus 3, 2y cubed minus 4y squared plus 4. So, remove parentheses, 3y squared minus 2y minus 3. Change all the signs inside the parentheses, minus 2y cubed. Minus and minus become a plus 4y squared minus 4. So I have a minus 2y cubed. 3y squared plus 4y squared is 7y squared. Minus 2y minus 3 minus 4 is minus 7. And so I've combined all like terms. 87. Eight u cubed minus 5 minus negative 6 u squared minus 3u minus 6. So 8u cubed minus 5. Change all the signs inside the parentheses. So plus 6u squared plus 3u plus 6. So I get 8u to the third plus 6u squared plus 3u. 6 minus 5 is 1. So I've combined all like terms. Almost every term there was not a like term, was unlike. 88, 89. 5 u squared minus 17 minus the quantity negative 3u cubed plus 7u squared minus 8u. Get rid of all the parentheses. 5u squared minus 17. Change all the signs inside the parentheses. Minus and minus become a plus. 3u cubed minus 7u squared plus 8u is equal to 3u cubed. 5u squared minus 7u squared is minus 2u squared plus 8u minus 17. And so I've combined all like terms. (91). Determine the perimeter of a triangle. So I want to determine the perimeter of a triangle. Whose lengths are 3x squared plus 7x minus 2, 4x squared minus 5x plus 1, x cubed plus x squared minus 2x. And so it is 3x squared plus 7x minus 2. Okay, and let's get this at a nicer angle. Four x squared minus 5x plus 2 plus 1. So recall that the perimeter of a triangle call this A, B, and C, then the perimeter is just the sum of each of the lengths of the triangle. It's the distance around. So once you start, it's the total distance that you travel along the edge of this triangle. So to find the perimeter of my triangle, I just have to add x cubed plus x squared minus 2x plus, I'll put the parentheses, plus 3x squared plus 7x minus 2 plus the third 4x squared minus 5x plus 1. And so let me get rid of all the parentheses. X cubed plus x squared minus 2x plus 3x squared plus 7x minus 2 plus 4x squared minus 5x plus 1. So this is equal to, well, there's only one x cubed term, so x cubed, x squared plus 3x squared, 4x squared plus another 4x squared is 8x squared, minus 2x plus 7x is 5x, minus 5x cancels. So these all cancel. 1 minus 2 is a negative 1. And that is your perimeter for the given triangle. Let me do problem number 93. So you're given a triangle. X cubed plus x, x to the fourth plus x minus 1, and x squared plus 2. Maybe I'll make that x cubed plus x. Okay. So it says, find the perimeter of the right triangle. So again, recall that your perimeter is just the sum of all the lengths. And so my perimeter is just x squared plus 2 plus x cubed plus x plus x to the fourth plus x minus 1. Get rid of all the parentheses. X squared plus 2, x cubed plus x, x to the fourth plus x minus 1. Combine like terms. So I have x to the fourth and I only have one x to the fourth term. I have x cubed and I only have one x cubed term. I have x squared, there's only one x squared term. I have x plus x is 2x. 2 minus 1 is 1. And that is the perimeter of the given triangle. Okay. And that finishes section 5.2. Oops, section 5.3. Yeah, so I guess we don't have enough time really for section 5.3. So that's it for today because we only have like 5-10 minutes or just a few minutes. So that's it for section 5.2, and that's it for today then. Okay, so I'll see you on Monday. Yes, I'll try to load all these notes and everything